Today's lesson is still a continuation of section 4.2, graphing linear equations. We're going to talk about one more new thing in this section that we can do this today and the next couple or next lesson here or so is graphing with a limited domain. We talked about a couple days ago what a domain is. Domain is the set of input variables. It's the numbers that we're going to plug in for our independent variable. Right here, x is usually what that one is. So the numbers that we're going to put in for x, they're going to show up right here in our table. But x is actually, domain means all the possible numbers we could plug in though. When I'm graphing equations with the class, usually I just pick out 0, 1, and 2, because again, those are pretty easy numbers to plug into an equation quite often. But a domain really means all the particular numbers that we could plug in. Well, then we'll look at the word limited. So again, it says graphing with a limited domain. So here's the phrase we want to make sure we understand, these two words. Domain means all the possible numbers we can put in for x in this equation. Limited means there's only certain ones that we can plug in. There's a boundary there. There's certain ones that we cannot put in for the x value. And as we graph, we'll see that these graphs will look just a little different than the ones we've been working with the last couple of days. So it's something we need to be aware of. So not every problem as we go on is going to be a limited domain problem, but it's something we should be able to handle, something we can think about, understand, and be able to make an appropriate graph. So that's what we're going to talk about. The last kind of new thing in this section that can come up when we're graphing is graphing with a limited domain. When we're graphing with limited domains, we're still going to do a lot of the same things we've been doing in this section. We're still going to find some ordered pairs. We're still going to put those in our table. We're still going to plot points on our graph. And we're still going to draw some kind of graph to represent the equation. But again, we'll just notice that what we get, the answers we get are limited. We cannot have every single answer. So there still might be an infinite amount of them, but answers for the equation, but not all of them are in play when they limit our domain. So here's what a problem might look like. It says graph the following equation and identify the range. I'll talk about range in 1 second. But first, let's worry about graphing. Y equals x plus 1. There's our equation. And in this case, we have a limited domain. It says x is greater than or equal to negative 2. So this domain says x is greater than or equal to negative 2. So negative 2 is a number, though, that could be a value for x that we could work with. Whenever you're doing a limited domain problem, as I'll talk about in class to the students, the first number you should plug in is that boundary. If they're saying that x has to be greater than or equal to negative 2, then that's the first number I want to plug in. I want to find out where is that boundary point, exactly where is that on the graph. That's going to help me make the correct, the accurate equation, the graph of the equation. So I need to plug that number in first for sure. So if the domain says x is greater than or equal to negative 2, I need to plug in negative 2. If that number was 5, I'd plug in 5. Whatever that number is, I definitely have to plug that one in first. Then we have to think a little bit here on numbers, other appropriate numbers we should plug in. So x is greater than or equal to, my x values have to be greater than or equal to negative 2. So again, they can be equal to negative 2, that's the boundary. And then I have to think of some other numbers. What numbers are greater than negative 2? Well, I guess I have to go this direction. I plug in negative 1 or 0. And I usually just plug in some other numbers that are right around that boundary. You could plug in anything. You could plug in 20 or 15 or 5 or anything that's bigger, but I'm just going to pick the numbers that are right one away from my boundary. So if I can plug in negative 2, that's the lowest I can go. The next one I could plug in is negative 1 and 0. I'm going that direction in terms of the x values that I could plug in. So that's the kind of the new thinking part, I guess, in terms of our graph so far, is I just have to make sure I pick the correct x values to plug in. After this now, a lot of it will look familiar. Now I'm just going to plug in negative 2, negative 1, and 0 in this equation and see what I get for my y coordinates. When I put in negative 2 for x, negative 2 plus 1 gives me negative 1. So that's what I get for my y coordinate there. If I put in negative 1 plus 1 gives me 0. And if I put in 0, 0 plus 1 just gives me 1. So again, this seems pretty familiar. Now I'm just going to plug my x values in, get my y coordinates, and plot these points. So that's nothing too new yet. Negative 2, negative 1 means left 2, down 1. Negative 1, 0 is right here. 0, 1 is right here. So now one more thing to consider though. Again, when we graphed before, I would just draw a line through those 3 points then. And there'd be the graph of my equation. And then again, that graph is showing all the possible solutions. But for these limited domain problems, with my domain limited, that means I can't plug in certain values for x. That means I can't get certain values out for y either. So there are certain solutions that should not show up on this graph because I can't get them. I'm limited, as it says, in terms of what I should be able to get. Well, think about this graph in terms of the left and right direction. Okay, that's the x direction. Really, here's the x-axis, correct? So it says that x can't be less than -2, as it says up here in my domain. X has to be greater than or equal to -2. Well, where's -2 along the x-axis here? Here it is, at this spot. I went from the origin left 2, and there's that point right there. Okay, that's that first boundary point that I plug in, and that's why I'm always going to recommend to students is whatever that boundary is, right here, that's the first number they should plug in. What we're saying is we can't go any farther left than that. So my graph of my equation shouldn't be any more left than this point. So it actually has to start at this point and then just go to the right. So here's what it actually looks like. I can get anything farther along the graph that direction. I can get anything where x is bigger than -2, but I can't actually go any farther that direction. I can't do it because -2 is the lowest point, most left point I can have for this equation. So this is what the graph looks like. And as I'll remind students, whenever you have a graph like this that has one point and then an arrow just going one direction, they remember this from some other unit or some other year, but this is actually called a ray. So sometimes when we're graphing with limited domains, the graph is actually a ray. It's one point, and then an arrow just going one direction from that point. So good. So far so good in this problem. The last thing we gotta do, as the directions say, is identify the range. So I haven't done this yet. Identify the range. Remember what the range is? That's all the possible y values we can get out of this equation. Domain is all the possible x values we can plug in. Range is all the possible y values we can get out. I'm going to designate range by just putting r and a colon. The range is going to look a lot like the domain looks. Here's the domain. So it's just x is greater than or equal to -2. I'm going to make some kind of inequality similar, except I'm going to have y values instead. Now we have to kind of switch our brain and think about y values. Here's the y-axis, correct? Y direction is up and down. So now the biggest help for me, as I'm going to tell the students, is look at the graph. What is the lowest possible y value I have? And then which direction should my inequality go, knowing that, okay, here's what the graph looks like. The graph looks like a point right here, and then it's just going up into the right this direction. It's going up. Okay. Well, here's my lowest point. Now think about up and down. What's this lowest point? What's this value in terms of the y direction? Well, here's the origin, and I've just gone down 1, right? So really this is at -1. And what am I talking about? -1 is my lowest value, and then everything else from that, we're at, it's like kind of like right here, we're at -1. And everything else is up from that. If I look at the graph, it's going straight up and to the right, but in general, just going straight up. So I'm only talking about values that are going more into the positive y's or above -1, correct? So my y values have to be greater than or equal to -1. Here's where y is -1 right here, and then my graph goes up from that. So I can't get anything. I can't get any y values that are down in this area. So my y values are all greater than or equal to -1. Again, these problems may seem a little tricky right away, but usually after the students start working with them and we go through some examples, usually they do get a lot easier. So we'll go through a couple examples here together, and I think we'll start to be able to put the pieces together. So here's another example we can go through together for graphing an equation that has a limited domain. Again, here's my equation, y equals x minus 4. It says graph the following equation and identify the range. Y equals x minus 4, but here's my domain. There's only certain x values that I can plug in. I can't plug in every single x value. It says x is less than or equal to 3. Again, my big hint that I'm going to tell students is whenever you see the domain as a certain boundary like that, plug that number in first. So I have to plug in 3 and find out what that point is, what that boundary looks like in my graph. And then now I just have to think, what other numbers can I plug in for this? It says x is less than or equal to 3, so I got to plug in numbers that are less than 3, right? So I can plug in 3, my boundary point, and then maybe points like 2 and 1, or 0, or -1, or any of those numbers. I usually plug in the ones that are right next to it, but you could plug in any numbers. You could plug in -3 if you wanted, but just have to make sure you plug in numbers that are less than 3. So then I'm going to plug in those 3 numbers, 3, 2, and 1. Then this part again is familiar. I'm going to plug in those 3 numbers and see what I get for y, so I'm just finding my ordered pairs. If I plug in 3, 3 minus 4 gives me -1. If I plug in 2, 2 minus 4 gives me -2. If I plug in 1, 1 minus 4 gives me negative 3. So again, there's me finding the ordered pairs. Again, just like the student should do. That should seem pretty familiar. I'm going to plot the ordered pairs, which also should be familiar. 3, negative 1, this is nothing new here. To the right, 3, down 1. To the right, 2, down 2. To the right, 1, down 3. There's my 3 points. But now here's where it gets just a little different than what we've done in the past, or the past couple lessons here. Usually I draw a line that just goes all the way through and arrows on both ends. But again, this is a limited domain problem. There's certain x values that should not show up on the graph because they're not possible solutions. So this says x is less than or equal to 3. Well, where is 3? Here's the origin. If I'm talking about the x-axis, where is 3? 1, 2, 3, right? So right here. So this line, what it's saying is any x value that works has to be less than that. So I must be going the opposite direction. I must be going to the left. And my points are kind of guiding me down like this. So I'll take my ruler, draw a line, and so that's the way my graph has to go. So, because again, that says x value. I can't get any x values right at that dotted line that I had there, because all my x values have to be less than 3. So there again, that's why I have students plug in this point first. This is kind of like your boundary point right here. But there it is. I'm making it the biggest one now on my 3. That was my boundary point. And then everything else has to be left of that because I'm talking about numbers that are less than 3. The range. Again, now for the range, identify that. I start thinking about in terms of the y direction. Now start thinking up and down as you look at the graph. Range, again, I can abbreviate r colon. I'm talking about my y values. I'm going to have some inequality and then some like number that it's greater than or less than of. Now start thinking up and down direction. Here's the y-axis. If I'm thinking in terms of ups and down, looking at this graph, here's the origin. I've just gone down 1. There's that boundary point, that highest point that I have here, and everything else is down below that. So that point, where is that? Well, it's just down 1, so that's negative 1. So negative 1 is going to be the number involved here in my inequality. And all numbers that are below that, it's going down this direction. So that would be less than or equal to, so there's my range. All the values in this line, as they're going down this way, I can get plenty of negative numbers, or numbers that are less than negative 1 for my y values, but I can never get anything bigger than that. So y is less than or equal to, all my y values that I want are less than or equal to negative 1. Last example we'll go through as a class, so one more time to practice it here. Graphing this equation. This is graph the following equation and identify the range. It has a limited domain here. It's telling us there's only certain x values we can plug in. So again, the first thing you should do is take that boundary point though here, 1 in this case. That should be the first number that I plug in for sure. And then now I have to think a little bit though, and that's alright, and you shouldn't be scared to think in math class, nothing wrong with that. It says x is greater than or equal to 1. So I have to think of numbers that are greater than 1, correct? So as I think of that, well, what's greater than 1? Well, 2 and 3. So those are the 3 numbers that I'm going to plug in for this equation. Then I'm just going to plug them in like we've been doing before. So 2 times, well, one of these numbers. Oops, and it's minus 5. So 2 times some value for x, and then minus 5. So in this case, first I plug in 1. 2 times 1 gives me 2. Minus 5 gives me negative 3. I was thinking it, but wrote the wrong answer. So I put in 1, I get negative 3. If I put in 2, 2 times 2 gives me 4, minus 5 gives me negative 1. If I put in 3, 2 times 3 gives me 6, minus 5, which gives me positive 1. So there's my ordered pairs. So again, that's nothing new. I'm going to plot those ordered pairs. To the right 1, down 3, right 2, down 1, right 3, up 1. There's my 3 points. But again, I'm not drawing a line all the way through them in this case because my domain is limited. There's only certain x values I can get out. That means there's only certain y values I can get out. So my graph has to show that there are certain solutions I cannot get for this particular graph. Again, here was the boundary point though, and you'll see it show up right here, 1, negative 3. So just know that's kind of the boundary, right? And I put points that are going to the right of that. So that's kind of maybe my hint that this is the direction we should go, and that's what I'm going to tell students in class also. If this is your boundary point is the first one, and the rest of the points go this direction, up and to the right, that's probably where your line should go too. Also, if I think about it, it says the domain is x is greater than or equal to 1, right? Well, again, here's x equals 1. And along the x-axis, there's x equals 1. I have to have all points that are to the right of that. I can't have anything over here because it says all the solutions have to be greater than 1. So I think it makes sense then that my graph is going to the right in regards to left or right. So good. Just got to backtrack here a little bit, get some of that out of the way. Now think about the range, and I'll just kind of write it up here this time. Range is going to be my y values. Well, in terms of the y values, here's the y-axis. And I've gone, where am I? It looks like I'm 1, 2, I'm down 3 along the y-axis. So here's that line. What is that? That's -3. And as I look at my values, they're all going up from here. I've got nothing going down this direction. So I have -3 and I'm above that. So all my y values that are solutions must be greater than or equal to -3. So there's the range of that equation. So again, graphing with a limited domain, I like these problems. They make us think a little bit. And there's nothing wrong with that, nothing wrong with thinking a little bit in math class. So they're different than just graphing any normal equation that doesn't have a limited domain, but that's okay. So we gotta kind of figure out what the range should be, what our graph should look like, where that boundary point is. Some important things to keep in mind when we're graphing one of these, but definitely something we can handle and something we're going to do in this particular section.